Hello everyone, welcome to the channel of DigiiMento UGC NET where we are going to discuss operating system problems. You can see our problem 1 which is which of the following need not necessarily be saved on context switch between processes. So options are general process registers, B is translation look aside buffer, and C is program counter, and D is all of the above. So what do you think is the correct answer for this? So we do not need to save TLB, which is translation look aside buffer, or cache to ensure correct program reassumption. Okay, so they are just bonus for ensuring performance. They are just for performance, just for knowing that the performance is better or not. But here if we talk about program counter and stack pointer, so I will talk about program counter, stack and registers. So these must be saved, otherwise program cannot resume. So that is why here correct answer we will say is problem B, like option B is the correct answer here. Now let's look at this question, everyone. So this question says, which of the following actions are typically not performed by the operating system when switching context from process A to process B? And there are some options below, which is option A is saving current register values and restoring saved register values for B, for process B. B is changing address translation tables. C is swapping out the memory images of process A to the disk, and D is invalidating the translation look aside buffer. Now here you need to understand one point. Processes are generally swapped out from the memory to disk, and here disk acts as our secondary memory. So the process, so here is the process, so it is swapped out. So let's say here is our RAM and here is our secondary memory. So the process is swapped out here, okay, from memory to disk when they are suspended. So processes are not swapped during context switching. And if we talk about TLB, so whenever any page table entry is referred for the first time, it is temporarily saved in TLB. So every element of this memory has a tag, and whenever anything is searched, it is compared against TLB, and we cannot get that entry or data with less memory access. And now if we talk about option D, which is invalidation of TLB, so this completely means that resting TLB which is necessary because a TLB entry can belong to any page table of any process. That's why resetting ensures that entry corresponds to the process that we are searching for. So can we say here that swapping out the memory image of a process A to the disk is the correct answer here? Yes. As we have seen option A, which is not correct, we have seen option B, this is also not correct, and D also we have C. And if we talk about option C, so because swapping out of memory image of a process to the disk is not done on every context switch, and it would cause a very huge head but cannot solve the problems like threshing. So that is why here we can say that option C is correct. And option B, because every process have its own paging table. And if we talk about option A, then when a current process is preempted, its activation recorded saved, and the data of the next process is restored by the OS. Okay, and if we talk about option D, then TLB holds record to the page table of current process. When a new process comes, it can be updated because the entries in the TLB may be pointing to some other page table. So clearly from here we can say that our option C is the correct. Now let's see the next question. The question says that the process state diagram is given below. So we have given a process state diagram and the options are, so you can see the process state diagram here. Running is there, ready is there, block is there, new is there, terminated is there. So all these are the states. Options are given as A batch processing operating system. Option B is an operating system with a preemptive scheduler. Option C is an operating system with non-preemptive scheduler, and option D is uniprogrammed operating system. So you have to understand one thing, that here when we talk about batch operating or uni operating, that is not the case here. You just have to see the transaction from running to ready, and this indicates that the process in the running state that can be preempted and brought back from ready to running state. Okay, so this is one of the important thing. That means a process is there and now it is brought into the CPU for running. After that, what can happen? It can be preempted. Okay, it is brought like this. It can be preempted again to ready state. So that is, this edge indicates that it is a preemptive scheduler. So option B is correct here, an operating system with a preemptive scheduler. And when C is correct, when we say that this edge is not there, running from ready, if this edge is not there, then we can say that here option C is correct. Otherwise, it is not correct. Otherwise, the edge is there. So definitely here option B is correct. Now let's see this question, everyone. So the question says, which combination of the following features will suffice the characteristic and OS as a multi-programmed OS? So which can say this? So option A, if we see, then more than one program may be loaded in main memory at the same time for execution. B is if a program waits for current events such as IO, other program is immediately scheduled for execution. Option C says if the execution of a program terminates, another program is immediately scheduled for execution. So here, if we talk about, so more than one process, if we talk about option A, this is true when only done in multi-programmed OS, not in single program OS. Okay, this is true when we are using a multi-program, not a single program. Now, if we talk about this one, which is if a program waits for current events such as IO, another program is immediately scheduled for execution. So if we talk about this, so this is only done in multi-programmed OS, not in the single program OS. Okay, so that is why A is also correct, B is also correct. But now if we talk about if the execution of a program terminates, another program is immediately scheduled for execution. So this is done in both multi-program and single program OS, because here see, if a single program, that means batch programming if we are using, if the process is terminated, definitely the other process will come, and this also happens in multi-program. Okay, so that is why we cannot say from C that this is particularly the characteristic for multi-programmed OS. So here C is not correct. So according to this, A and B are correct. So we can say that option B is absolutely correct. Now let's see the next question. So you can see this question. The question says, which one or more of the following need to be saved on a context switch from one thread, which is T1 of a process, to another thread, which is T2 of the same process. So first, if we talk about page table base register. So this register holds the base address of the page table for currently executing thread. And since all the thread of the process share the same page table, so this register need not to be saved. So that is why we can say that A is not the correct one. But if we talk about stack pointer, so this register points to the top of the stack value, as you all know the property about stack pointer, and each thread has its own stack. And the stack pointer needs to be saved and restored on a context switch to ensure that new thread uses the correct stack value. So that is why here this should be saved, stack value should be saved. So B is correct. Now if we talk about program counter, So this register contains the address of the next instruction. So program counter, you all know, PC. If these are our instructions, and let's say this is 500, this is 501, and if we are executing 500 instruction, then program counter will save its next instruction address. So to resume execution of the new thread, the saved program counter needs to be loaded into the program counter register. So that is why here we can say that option C is also correct. Now let's try to see general purpose register. So these registers are used to store temporary data and immediate results during the execution of thread. The state of these registers can be different for each thread, and they need to be saved and restored on a context switch. So here we will say that stack pointer is also important, program counter is also important. After that, general purpose register is also important, because this must be saved before a context switch between threads or between processes, we can say, to ensure correct execution of the program. Okay, so that is why here this is completely a MSQ type of questions, where option B, C and D are absolutely correct. Now, can you just solve this question? Because this question we have already seen, but there is a little modification to this question. So I am giving you 1 minute time to think about it, and after that we will discuss what is the correct answer. And I definitely know that you will be able to solve this, because see, this problem we have seen, and little modification also I have told you, so that you can solve this question. Okay, so your time is up. Let's see the question. The process state transition diagram of an operating system is as given below. Which of the following must be false about the operating system? Now here, how many state diagram is given? 1, 2, 3, 4, 5. 5 state diagram is there. Start is there, where the process is brought from secondary memory to RAM. After that, a new process, create a new process. It is brought in the RAM in the ready state. After that, scheduling of a process is done by a dispatcher to run the process on the CPU. Okay, and after that, once it is completed, it is terminated. And while running, if the process wants to go for any IO operation or any resource thing, then it will get blocked. And once again, it will be, when the blocked operation is completed, it will be again into ready state. So this is our transition diagram is. This is our process state diagram is. Now, it is a multi-programming operating system. Definitely it can be, but this is what it specifies. Okay, and the question you have to highlight this, that which of the following must be false about the above operating system. Generally what happens is we just ignore this word and we mark the answer as correct, and that is where we make mistake in exam. We have to highlight such words which is false. So we don't have to take the correct answer, but we have to take the wrong answer, which is the false one. So it is a multi-programmed operating system. This is a correct statement, right? We can, by this we can run a multi-programming operating system. So this is definitely not our answer. This uses preemptive scheduling. Now, is there any edge from running to ready? If there is edge, then we can say that it is preemptive system. But as in the question, there is no edge. So definitely B is our answer. It uses preemptive scheduling, which is false. And this is correct one, right? It uses non-preemptive scheduling. This is also correct, because there is no edge from running to ready. So it is definitely, we can say that it is definitely a non-preemptive system. And after that, if we talk about it is a multi-user operating system, then we can have multiple user processors in ready state. So that's why this is also correct. So the only answer which is false and the correct here is it uses preemptive scheduling. So I hope you got this question, everyone. Now let's solve this question. So this is a little like a tricky question where you have asked to solve SRTF. Okay, so consider the following set of processes with the arrival time and the CPU burst gives you milliseconds. Okay, so processes are there, arrival time is there, burst time is there. What is the average turnaround time for these processes with the preemptive shortest remaining programming time first algorithm, which is also called as SRTF? Okay, so you have to make a Gantt chart for this. You have to see the completion time, you have to calculate CT. After that, for TAT, the formula is, so TAT, how you calculate? Everyone can answer in the chat box. It is CT minus arrival time, completion minus arrival time. And once you calculated all this, after that, what you have to do? You have to do the sum and you have to divide it by the number of processes. And this will give you the average turnaround time. So I'm giving you just a minute, okay, 1 to 2 minutes. Please solve by yourself, and after that we will definitely discuss what is the solution. Okay, so time is up, everyone. So let me tell you how to solve this question. First of all, SRTF, we have to understand that here we have to take the criteria for this is we have to take the shortest burst time. Okay, and this is a preemptive one. So we have to make Gantt chart with so much of focus. So let's try to make this. So we will make our Gantt chart. And the Gantt chart always starts with 0. So at 0, we can see that P1 process is arrived. Alright, so we have to run P1 process till 1 unit because here the shortest burst time is coming. So that is why for just 1 unit, we are going to run P1, and here now this will get subtracted by 1 because we have already used this for 1 unit of time, and now this will be 4. After that, here P2 will come, and now P2 will run. So P2 will run till 3 units of time because 3 and 3 are there. So if both of them are same and this is arriving, so definitely we will definitely we will run P2 on the CPU, and we are not going to preempt this because even if we are going to run this for 1 unit, so it will have the smallest burst time. So this only we have to take completely. So if we take it completely, so till 3 unit of time and it will be 0. So it will be, so P2 will run on CPU till 1 to 4 units of time. And after that at 4, you can see that P4 is coming with the shortest burst time. So we have to consider P4 to run on the CPU, and it will take time for 4 to 5, which is just a unit time. And this is completed. After that, the only process left, which is P3. Okay, so 2 processes are left, which is P3 and P1. So P3 has the shortest burst time. So we have to take that completely. After that, P3, so once all the processes are came, we can just, without any preemption, we can just run the processes. So here 3 unit time, so 5 plus 3 will be 8. So P3 will run till 8 unit of time and it will get 0. After that, only process left, which is P1, and it will run from 8 to 12. After that, we can see here the completion time of P1 is 12. The completion time of P2 is 4. The completion time of P3 is 8, and the completion time of P4 is 5. So these are all the completion time. Now if we calculate the turnaround time for this, so it will be, so 12 minus 0 is 12. Okay, 12 minus 0 is 12, 4 minus 1 is 3, 8 minus 2 is 6, and 5 minus 4 is 1. Now we will add this. So 12 plus 3 plus 6 plus 1, and we will divide it by 4. Now can you just quickly tell me the calculation? What is the value we are going to get? So 12 plus 3 is 15, 15 plus 6 plus 1 divided by 4. So are you all getting 5.5 as the answer? So here option A is correct because we are getting 5.5 as the answer. So this is the way to solve this question. Let's see the next question, which is this one. So the question says that there are 3 CPU intensive processes which require 10, 20, 30 time units, and the arrival time is also given below, which are 0, 2, 6 respectively. After that, it is given that how many context switches are needed if the operating system implements shortest remaining time first algorithm. Do not count the context switches at the time 0 and at the end. So this is clearly given to us that whenever we are making a Gantt chart, it will be starting from here, it will be ending, let's say, here. So this and this time we don't have to calculate in our context switch. So let's make a table for this quickly. So as you can see here, process is there, arrival time is there, burst time is there. Process is P1, P2, P3. Arrival time you can see is 0, 2, 6. Burst time is given as 10, 20, 30. Now let's make a Gantt chart for this. So Gantt chart if we will make, so this process P1 is coming at 0 time unit, and as this has the shortest burst time, so it will completely run. Okay, this will have no preemption, it will completely run till 10 unit of time, and after that it will get completed. Then at 2 and 6 all the processes, till 10 all the processes are arrived. Now here the shortest burst time we can say here is of P2, which is 20. So this will run till 30 units of time, and after that the only process left is P3, and this will run till 60 unit of time. Now here we can calculate the arrival time. But here are they asking about arrival time, completion time? No. The question says that how many context switches are needed, and they have said that this and this we are not going to consider. So at 10 and 30. So at 10 and 30 there are only 2 context switches which is happening at time 10 and at time 30. So that is why here B is our correct answer. Now let's see the next question. So this you can see, in an operating system, indivisibility of operation means. So here option A is operation is interpretable, race condition may occur, processors cannot be preempted, and the D is all of the above. So here we have to make some assumptions that we have to assume that we know about assembly language. So whatever you see executed on CPU is nothing but instructions, and these instructions are predefined and known to be processors. Processors, if we say, so currently we are using like Intel core, and all the processors name you know. So in certain cases, to avoid race condition, atomic individual operations are preferred, and these indivisible operations are executed in one clock cycle. That is why here we can say that the correct answer is C, that processors cannot be preempted. Processors cannot be preempted. Now let's see the next question. Which of the following is correct value written to the operating system upon successful completion of a program? So what is the value written? A is 0, B is 1, C is -1, and D is program do not return a value. So here the correct answer to this is option C. Program returns -1. No, it is not C. It is program returns A, which is 0 value. So 0 is by default, which returns the program or terminates the program. So that is why 0 is the answer. And in C and C++ programs, the main function is of type int, and therefore it should return an integer value. And the integer value of the main function is considered as the exit status of the application. So on most operating systems, 0 is a success status, like the program is worked completely fine. So that is why option A here is the correct one. So this is all. So for you all, this is a homework question. So if you have seen complete practice course, so you can just answer this question in the comment box, and I'll check that whether you have given the correct answer or not. So if you really like the video and if you have done practice, so please subscribe the channel and please like this video. And till then, see you in the next video. Thank you so much, everyone.